All right, we're going to go over a few competitive math questions here, and I'm only going to solve a couple of them because I don't have time to do them all, and I will do the rest of them for my members in the 100x math plan. All right, so we'll just talk about the first few here. On Valentine's Day, every student in a particular class gives a Valentine to every other student. Total of 156 Valentines were exchanged. Compute the number of students in the class. All right. That one we will not do. A committee, it's pretty easy. A committee has 7 men and 5 women. 7 men and 5 women. Pardon my handwriting. From these people, a 5-person subcommittee is formed. Whenever they ask for something like this, whenever I like to think of it in terms of slots. A 5-person subcommittee is formed. Compute the probability that someone in the subcommittee. Compute the probability that the subcommittee has 3 men and 2 women. Okay, we're not going to do that one either. That one will be inside the program. All right, in the sequence 6AB16, the first 3 terms are in arithmetic sequence, and the last 3 terms are in geometric sequence. Okay, so let's write it out. Always write it out. Don't try to do this in your head. 6, comma, A, comma, B, comma, 16. They're telling us the first 3 terms, 6AB, and I use capital letters because A can look like a 9, lowercase a can look like a 9, and lowercase b can look like a 6. Don't be afraid to do this. All caps, you can be yelling. 6AB are an arithmetic sequence. That means that A, you should think this right away, A is the average of 6 and B. A equals B plus 6 over 2. And A, B, 16 are in geometric sequence or in geometric progression. That means that B is the geometric mean of A and 16. That means B is the square root of A times 16 or 16 times A. Great, we have 2 equations and 2 variables. We're just going to substitute in. B is going to be equal to 4 square roots of A. I don't like to say rad A, 4 square roots of A. And we're going to substitute this right in here. A equals 4 square roots of A plus 6 over 2. Multiply both sides by 2. We get 2A minus 4 square roots of A plus 6, not plus 6, minus 6, knucklehead. Minus 6 equals 0. Divide everything by 2. We're getting no more 2. We're getting A minus 2 square roots of A minus 6 equals 0. We're going to factor both sides. This is a quadratic in disguise. We can make another substitution, but that would complicate things. I think you'll see that it's the square root of A times the square root of A. Those are our first terms that get, when we multiply it out, we get A to the first power here. Actually, no, that's not minus. This is minus 3. Please stop making mistakes. It's annoying. It's annoying. I know there's people out there just dying to catch my mistakes. I used to do that in the back in math class too. 2 numbers to multiply to -3 to add up to -2. So it's square root of A minus 3, square root of A plus 1. That means that the square root of A equals 3. Or the square root of A equals -1. Well, when the square root of A equals 3, A equals 9. And when A equals 9, we go 6, 9, 12. They have to be going up 3. And we have to be 9, 12, 16. 9 times 16 equals 12 squared, 144. All right. If A, the square root of A is -1, that would mean that A would be 1. So we'd go 6, 1, and looks like we're going down. We're going down 5 in our arithmetic progression. 6, 1, -4, and then 16. Is this actually right here a geometric progression? Yes, 1 times -4 is -4, and -4 times -4 is positive 16. So those would be our ordered pairs. So A would be 1, comma, -4, or A would be, what did we get? The other one, 9. 9, comma, 12. All right. All right, we're going to look at this 2x plus 3y to the fourth. We have to remember our binomial expansion coefficients from Pascal's triangle. So if we have something raised, a binomial raised to the fourth power, we know the coefficients are going to follow this sort of pattern. I'm not going to get into it right now here in depth, but that's the type of stuff you need to look at. So our first term will be 2x to the fourth plus 4 times 2x cubed 3y plus middle coefficient 6 times 2x quantity squared. Be careful here. 3y squared plus 4 times 2x to the first power 3y cubed plus lastly just the 1 in front, it will be 3y quantity to the fourth power. Now let's start doing this out. I'll switch to black. We need to add up the coefficients, so actually these variables aren't going to matter that much. Our first term is going to be 16x to the fourth, but this x to the fourth really isn't going to matter that much. Okay, we can almost assume that x is 1 and ignore it. We're only adding up the coefficients. All right, back to black. Now we have 4 times 2 cubed, 4 times 8 times 3. Those will be the sum of the, or the product of the coefficients here, ignoring the x and the y. Our third term, we're going to have 6 times, this is 2 squared is going to be 4. 6 times 4 is 24. And that's going to be 3 squared, that's going to be 9. Our fourth term is going to have a 4. 2 times 2 is 8 times 27. 8 times 27. And then our last term, 3 to the fourth, of course, is 81. And again, these terms here, they'd all be here if we did an actual expansion, but the x and y terms don't really matter. Yeah, we can just assume that they're 1. So let's add these up. Maybe I made a mistake. Maybe I didn't. 16 plus, let's see, that's 32 times 3, that's 96. Plus 24 times 9, that's 240 minus 24, which I think is 216. 8 times 27 is 160. It's going to be 216 as well. Is that right? 216. 2 cubed times 3 cubed is 6 cubed. Yeah, 216 again. Is that right? Yeah, that's right. Plus 81. So it looks like 432. 432 here. 96. Add 100. Come back 4. 528 plus 97. I feel like I made a mistake here. Plus 97 would be, no, 625. That's right. Okay, now something you might notice here, 625 you should know is actually 25 squared, or 5 to the fourth power. Now remember what we did here at the end, we kind of ignored the x and y's. We said we can almost assume, we said they don't matter, or I said they don't matter, but you can almost assume that they are 1s, right? And if you assume that they were 1s, if you went up in here and said 2 times 1 plus 3 times 1 to the fourth power, you would actually get 5 to the fourth power. I'll write it bigger here, 5 to the fourth power. So 625 is the answer. Now let me look at this next, well, let's skip the geometric question for a second, or maybe we'll set the geometric question up. And I'm not going to do that one. It's not a tough question, but I'm not going to do it here. Let A, B, C, D, E, H, G, F be a cube of side length 2. Let M be the midpoint of that segment of the segment FG. And we got some stuff cut off, A, B, C, D, E, F, G, H. Let M be the midpoint of FG. Let N be the midpoint of GH. We want to find the area of triangle D, M, N. Okay, that's not a tough question. But again, I'm not going to do that one right here. A couple other ones I want to do. Let's look at this last one here. They'll use Pythagorean theorem a couple times, and again, I'll show you that in the members video. Compute the sum of the reciprocals of these roots. The roots of x to the 4th minus 3x cubed minus 5x squared plus 5x minus 8. Okay, let me write that out here. And this is a question that if you know how to do it, it's just very simple question. These are the ones where those who prepare, win, because unless this is relatively easy to factor, there's really no other way to do it. We need to understand that we need to understand the relationship between the roots of an equation and the coefficients. So when the lead coefficient here is 1, which it is, these are what our roots would look like. Well, maybe I'll do it down here because we need more room. So x to the 4th minus the sum of the roots, r1 plus r2 plus r3 plus r4. Sum of the roots taken one at a time times x cubed. Then it will be plus the sum of the roots taken 2 at a time. So it'll be r1, r2 plus r1, r3 plus r1, r4 plus r2, r3 plus r2, sorry, r4, you have to listen to me, don't go by just what I'm writing, plus r3, r4 times x squared minus the sum of the roots taken 3 at a time, r1, r2, r3 plus r1, r2, r4 plus r1, no capital, r3, r4 plus, now all the roots except for 1, r2, r2, r3, r4, there's 4 of them, times x, and then it will be plus product of the roots. R1, R2, R2, R3, R4. Now you can look this stuff up in lots of different places. You should be in your book as well. But again, when they want us to compute the sum of the reciprocals of the roots, we need to know something about the roots. So what they want us to calculate, and I'll have to move this up, the sum of the reciprocals of the roots. What is that sum? Well, how do you add fractions? You need a you need a common denominator. Our common denominator is going to be the product of the roots, right? The product of the roots. We're going to end up with R2. Let me just create some space here. You got all this? Because I'm going to have to use this space. Okay, I'm back. So the sum of the reciprocals of the roots, let's just write it all out here. 1 over R1 plus 1 over R2 plus 1 over R3 plus 1 over R4. It's actually equal to I keep going to capital, R2, R3, R4 over R1, R2, R3, R4. We're just getting a common denominator here, plus the product of the roots except for root 2, R1, R3, R4 over R1, R2. This is getting tedious to write out. R4 plus R1, R2, R4 over the product of all the roots again. hard to write and talk, hard to write and talk, plus R1, R2, R3 over the product of the roots, which is again our common denominator. All right. So when we add them all up, we basically have, we are over the product of the roots, which is really -8 plus minus. Actually, the product of the roots minus plus is -8. And the sum of the roots taken 3 at a time is going to be -5, I believe, which is 5/8. Let me just check this for a half a second. I'm sure if I make a mistake, someone will correct me. But basically, it's the product of the roots taken 3 at a time over the product of the roots taken all at once, or basically the product of all of them. And the signs, yeah, we should get 5/8, right? Because it's going to be the opposite of this. Opposite plus opposite plus. The opposite of the 5 over, yeah, and 5/8 will be our answer. I'm going to do maybe one more question here. Okay, we'll do 2 more questions because this one here is so easy. It's worth, well, it's important. 3 different faces of a rectangular prism have areas 15, 24, and 40. A rectangular prism, of course, is also known as a box. And this question here, they set it up so easy that you could guess it. Okay. So basically, let's slow down and talk about let's call the sides A, B, and C. I don't like L, W, and H. And if we know the areas are 15, 24, and 40, you can guess that it's 3 by 5, 3 by 5, 3 by 8, and 5 by 8. This is guessable. All right. If you just guess, 15 doesn't factor into too much. 3 by 5 by 8, and you can do it this way. But I want to show you the better way to do it, the better way to understand it. All right. So ABC. If we know that ABC or AB equals 15, and that AC equals 24, and BC equals 40, then we could multiply them all by each other, right? AB times AC times BC equals 15 times 24 times 40. And that also means A squared, B squared, C squared equals 15 times 24 times 40. And in order to find the volume, remember volume is the product of all the dimensions, A, B, C, you would just take the square root of both sides. So you would take the square root of 15 times 24 times 40. All right, and you're going to have a lot of, when you take the square root of this product here, it's actually this, right? No, it's not that. It's actually, yeah, it is actually that. The square root of that, because we take 1 3 out, 1 5 out, and 1 8 out. All right, so that's how we do it. All right, one more question. I said I would do one more. We'll do 2 more. Okay, this one at the top here. Compute 2009 squared plus 10,049 divided by 2010. Now, all algebra, as I say over and over and over again, as I was taught, is factoring. Right? They don't actually want you to square out 2009 and get a big number. Add 10,049 to it and divide by 210. You can do that, but you're not gonna have a lot of time to do this next question, which is in that same team round. Again, this is a competitive math exam from New York from a bunch of years ago, and you would probably have 10 or 12 minutes to do these 2 questions. I'm not sure exactly how they do it, but the faster you go with the first one, or the slower you go with the first one, the less or more time you have with the second one. So let's just look at this right here. Whenever you get stuck, your reflex should always be to say, well, all algebra is factoring, and I see a square in there. And what if we need a variable? What if x equals 2009? What would that mean? Well, here's what it would mean. It would mean we'd have x squared plus, whoa, how do we write 10,049 in terms of x? Well, to go from 2,000 to 10,000, we multiply by 5. It looks like it's 5x. Well, 5 times 2009 is 10,045. 10,045. Well, we need 4 more to get to 10,049. 2010, that looks like, to me, it looks like x plus 1 if we're going to make this substitution here. Factor at the top, x plus 4 times x plus 1 all over x plus 1. Awesome. Cancel, cancel. Our answer is x plus 4, 2009 plus 4, 2013. Done. All right. If you want to see me solve the rest of these questions and have a whole bunch more, look at the link below in the description. I'll see you in the next one.